Good morning, everybody. This is a Toshiba C850. Let me just get the exact model number. It is a Toshiba satellite C850. This was sold as a bunch of PCs that I bought from a second-hand site, and this is not powering on, as you will see. There's no keyboard in this either. But what we're seeing happening is, first of all, our power jack is good. It's plugged in. I press the power button and nothing happens. Okay, nothing. Now, on that little fuse right there, I'm measuring 19 volts. So 19 volts is getting onto the board. But I'm going to take apart this motherboard and then we're going to have a look at it. I've checked the power adapter and the power adapter is good. So the next step then is to take out the motherboard. On these C850s, it's a horrible job to get out. These motherboards are buried in it. You have to take out screws from the top and the bottom. But it's done now anyway, and here it is. I've taken a couple of pictures of it. We're going to start on the back where the power comes in. So if you see right up here, I'm going to zoom in on this section right here. So this is where we have our wires. So as you can see, we've got two black wires here, two red wires here, and this is where they hit the motherboard. So our two red wires come to this point here, and that's where we follow our 19 volts. So I'm going to take a few voltage measurements as usual to start with. So we're going to introduce our multimeter and we're going to stick it on volts DC, then get our black probe, stick it to ground right here, and then introduce our red probe. And let's start taking some measurements. Okay, so to start with, we are going to check. We've got our two sets of wires right here. Okay, so we've got our black wires here, which are our ground, and we've got our two red wires right here. Unlike the Dell we did last week, the Toshibas only have two. They have a ground and they have the positive voltage. They don't have any sort of ID pin, so it makes them a lot easier to work with. Plus they're marked as black and red, so you know exactly where you're going. These are the ground, these are the positive voltage. So these connect, when you see it on the other side, to these two pins here. So when I place my probe right here, I get 19.3 volts. So this tells me that our power jack is good as well as our adapter. The first component in our path is this component right here. So I think this is an inductor. So what we're checking here is to make sure that our 19.31 volts is making it through this component. So I place my probe right here. My other probe is still on ground, and we measure 19.31 volts here also. Now this goes up here and onto this fuse. So I'm just going to mark on it there the path that takes. And what we want to make sure is that the 19.31 volts is on the other side of the fuse also. So I take a measurement here, and there's 19.31 volts there also. So the path, it's a bit of a circuitous route that this takes right here. So the path that the voltage takes after this is actually down and onto these four pins right here. So you can probably guess immediately what that component is, but I'm going to mark out the path that it's taken. So it goes right here and onto these four pins. So we're going to look up the model number of this component right here. It's an IOR and then it's F8707. So we're going to take a look and see what that is. From previous examples that we've done, you can probably guess that this is some sort of MOSFET, either an N channel or a P channel. So I've googled the model number on the chip and this is what it is right here. It's an IOR rectifier, it's called here, but it's actually an N-channel MOSFET. So you can see the pins on it. We've got pin 1 is source, 2 and 3 are also source. Pin 4 is the gate, which controls the MOSFET, and then we've got pins 5, 6, 7 and 8, which are our drain pins. So this is pin 1 right here, which means these are our 4 drain pins. And we have, when I measure here, we have 19.31 volts. So the question is this MOSFET being turned on, and is it 19.31 volts on the other side? Well, if we mark out those pins, what we can see is that these are our 4 drain pins, these are our 3 source pins, and what's meant to happen here is if this gate pin is high, then that switches on the MOSFET and we should be seeing the 19.31 volts on our source pins also. So what I'm going to do next is I'm going to measure the voltage at the gate pin and just see is it turned on. Okay, so I get my probe and I place it right to this gate pin right here. And when I measure that, I get 24.8 volts at that. So that tells me that the MOSFET should be switched on at this point. And sure enough, when I measure on any one of our three source pins right here, because these are all connected together, so I measure right here and I also get 19.31 volts at this point. So from here, our next component in line is this second IC right here. So to me, this looks like this may be the second MOSFET in our 2 MOSFET configuration, because I can see after that there's a current sense resistor right here. So let's get a look at this one and see exactly what this is. I can see on that it's an 8884 or something like that, but I'm going to see if I can get the data sheet for this one as well. Okay, so I found a data sheet for this. So this is an FDMC8884. It's an N-channel power trench MOSFET. Okay, so let's get a look at it right here. So let's take a look at the pinouts again. So pin 1, 2, 3 are source, and then pin 4 is gate, and then drain pins all on the other side. Okay, so what I'm going to do is I'm going to mark those out. So if we look at our MOSFET as it is right there, this is what it looks like. So we've got all our source pins on this side, and because it's an N-channel MOSFET, we need this gate to be high for the 19.31 volts to pass across to our drain. So when I measure this gate right here, I find that there's 24.8 volts on it, and that means that the MOSFET should be switched on. And when I check on the other pins, there's actually other little pins right here that you can't really see in my image, but when I measure right here in any of these 4 pins, because they're all drain pins and they're all connected together, I measure 19.31 volts. So that tells me the MOSFET is turned on and everything is okay. The next component in line is this current sense resistor right here. So as we know, with a current sense resistor, its only purpose is to cause a slight voltage drop through a known resistance, and this allows us to measure what the current through that device is, and based on the current going through it, it can detect if there's too much current and then pull the system. So on the other side right here, I measure and we get 19.31 volts also, and this is our main 19 volts power rail right here. Okay, so I'm just going to do a quick review of where we are at the moment. So I measured at the start and we've 19.31 volts coming in onto the laptop motherboard. That goes through an inductor, then through this fuse right here, and through our MOSFET, our first MOSFET, onto our second MOSFET, through our current sense resistor, and I'm reading 19.31 volts here. Now this should be going out to all of the other secondary power supplies. This 19.31 volt should be the input basically to all of the other circuits. So what I'm going to do is I'm going to go around the other different secondary circuits on the motherboard and see that 19.31 volts is present. This is the front side of the motherboard. Just one quick note before I go any further. I've put a bit of time into trying to make these images a little bit better and trying to reduce the time taken to do them, because it's very time consuming manually stitching these together. But as you'll see with these, I think I've managed to make some progress. So if I zoom in on that, that is 100% there. That's, you know, the image as it was taken, but you can see there's very, very good definition. You can even see the lines on that processor there, and you can see most of the markings on the chips as well. So here's what I'm looking for. So we knew we had our 19.31 volts at our current sense resistor. So what I'm doing here is I'm checking capacitors out on the secondary circuits to see if that 19.31 volts is available there as well. So as you can see, I think these are the circuits for producing our V-core. And as you can see, I'm measuring 19.31 volts here. I'm also measuring it down at this capacitor here and these 2 capacitors right here. Further down the circuit, I'm also measuring 19.31 volts down right here at this point. I'm not actually sure what that one has to do with. Maybe it's the 5 volt power rail, or maybe it's for the chipset. So if we look back up then again towards the top of the circuit, I'm also finding that there's 19.31 volts at this right here. I know that chip, that TPS51216, produces the memory voltage, so I think that is the input to that circuit there. But this up here then, I think this is the battery circuit, so there's 19.31 volts here, but that's enough to tell me that our 19.31 volts is making it out to all of the other secondary circuits. So I guess at this stage the next thing really to try is to see if we're getting our 3.3 always on voltage and our 5 volts always on. So I'm going to try and search and see if I can find the chip that produces our 3.3 always on voltage and our 5 volts always on. So let's do that next. Okay, so I think I found our 3.3 volt and 5 volt regulation chip. Can you see it from here? I'll just zoom in step by step and see if you can work out where it is. Some of the text came out really well on this, but as you can see, do you remember the number of this? 1225C. Well, here it is here. So what I did was I measured the voltages around this just to see what was on it, and hopefully this comes out clear. But I found 19.31 volts on this capacitor here, so that's obviously the input voltage for the chip. And then I found on the capacitor right beside it that there was 5 volts on this. And then on the other capacitor over to the right, I found that there was 3.3 volts right here. So what does that tell us? Hands up, anybody who has the answer. Well, what it tells us is that that chip is essentially working. Well, the LDO, the unregulated voltages, the always on voltages appear to be on. And that's the next step that we need to see on this. So we've got our 3.3 volts. So again, what's the next step? See, is that 3.3 volts on the power button? I flipped the board once again just to see where the power button was connecting, and as you can see, this time we have a pretty good image of the power button and the connector connecting to the board. So there's no ambiguity over it here. This is our power button sort of daughter board. There's a cable that connects from that board, and there's 4 pins on it right here. So what I did was I got my black probe, placed it to ground, and again in volts DC I brought in my red probe and just checked each of these pins right here. And what I found was that when I placed my probe to this pin right here, the one at the top, I read 3.3 volts at this. So our 3.3 volts is being generated by our 1225C chip, and it's making its way out to here. And when I press this button, that 3.3 volts goes to 0 volts. So that tells me that my power button is also working. So it's not a really easy fix with a dodgy power button or anything like that. Further to that, what I wanted to do is make sure that that signal was making its way all the way down to our startup chip. So as I zoom out here, you can see that this looks like our startup chip right here. So what I did was I got my red probe and I placed it around the chip on just the different capacitors. I could measure 3.3 volts on a number of these, and I pressed the power button to see if it was, sending that signal to my startup chip. And what I found was that if I went down to this little, I think it's an inductor down here, I measured 3.3 volts right here. But when I pressed the power button on this laptop, that went to 0 volts. So I'm certain that the startup chip is getting the signal from the power button. It's 3.3 volts. When you press the power button, it goes to 0 volts, and that signal is being sent to our startup chip right here. I'm going to stop this video right here. I've changed the software that I'm using for producing the videos, so that has been very, very time consuming this week, but it's with a view to making the videos much easier to make in the long run. So I'm not too worried about that. I know it's going to be better into the future. But where we are with this laptop at the moment is that we have our 19 volts main power rail. We have our 3.3 volts always on. It's present at the power button. When I press the power button, it's going to ground, which means that the power button is working. And I've also confirmed in our last step that our Super I/O chip is getting the signal from the power button, and yet still our laptop is not powering on. So the question is, why is my laptop not powering on? And maybe that's a question I can leave hanging for you guys. What is the next step when we reach this point? I press the power button, the signal is sent to the Super I/O chip, but the laptop is not powering on. Do we have a bad Super I/O chip? Is it detecting that there's a fault with another part of the circuit? Check out next week and we will find out why. Please like and subscribe and leave any comments that you might have down below. Thanks for watching.